In section 2.6, we're going to talk about families of functions. So in this section, this kind of might remind you of in geometry where you had a shape and you would shift it by translating it or rotate it or reflect it. Here we're going to have a parent function, and what we're going to do is move it around in the coordinate plane or stretch it out. So to start with this, let's talk about what a parent function is. A parent function, by definition, is the simplest form in a set of functions. So what you see on the bottom left-hand corner here is the parent function for quadratics. F of x equals x squared is the simplest quadratic function that you could have. Each function in the family of quadratics is a transformation of that parent function. So an example of this would be something like f of x equals x squared minus 4. As we can see, it's still basically the same function, it's just shifted 4 units down. So that would be an example of a translation. For translations, we're going to focus on if you can translate something horizontally or vertically. For horizontal translation, we need to add or subtract a number within the input. So we see we have the parent function f of x. If I want to move something to the right, I would have something like f of x minus h. The key there, that number that we're subtracting is in the parentheses. Similarly, if I want to move something to the left, I would do f of x plus h. Again, the key here is if we want to do a horizontal or left to right shift, we're going to add or subtract the number within the parentheses or within the input. On the other hand, if I want to vertically shift something, I need to add some number k to the output of the graph, and that'll shift it up or down. So again, I have the red function, that's the parent function f of x. If I want to move it up, I would add some value k to the output, and if I would want to move it downward, I would subtract some number to the output. The last thing that we're going to talk about is vertical stretch and compression. So here, if you kind of look at the graph, that might help you understand this a little bit better. This blue function here is our parent function, f of x. If I want to stretch it, think about if you had a hand on like the top and bottom of this graph. So I'm pulling at it, I'm stretching it out. How I would do that is by multiplying all of the output or y values by a number greater than 1. For compression, on the other hand, I would need to multiply all of my output values by something, I guess to be more specific, between 0 and 1. So some number between 0 and 1 is going to give you something that looks like that blue graph or like you're smushing it down. In summary, the three translations we're going to look at, or transformations, are vertical and horizontal translation and then vertical stretch and compression. For vertical translation, I need to add or subtract a number from the output, like what you can see here. For horizontal translation, I need to add or subtract a number in the input. The key there is in the input. You'll see that number in the parentheses. Last but not least, for vertical stretch and compression, I'm multiplying that whole function by a number greater than 1, that would be a stretch, or a number between 0 and 1, that would be a compression.